welcome to this MagiCAD webinar. The topic for today is boost your takeoff by 50%. So the product or the solution that we look at is called Cubicost, and I'll be presenting this webinar with my colleague Ehsan Raja. So we have a really simple agenda for today. I'll just explain in one of the slides as to who we are as an organization and what we offer. We will also show you some of the current customers and the testimonials that they've given us. We will compare as to what we mean when we say a measurement only approach versus a measurement and model approach, something that we offer. And we will show you some of the boosters that you get access to with the measurement plus model approach with our platform. So who we are. So we are actually Glodon Group. We have our headquarters in China. And if you look at some of the blue dots here, it shows that we've got a really strong presence in China and Southeast Asian market. So we've been going around for 20 years, and we've got a solid reputation for building highly automated BIM-driven tools for the construction market. Now, MagiCAD Construction Solutions is actually a brand that comes from Finland. A very well-reputed brand that's known for MEP software, MEP design software products. But back about 5 or 6 years back, Glodon acquired MagiCAD, and now we are offering some of the Glodon products under the MagiCAD Construction Solutions banner. Now, who is using Cubicost products? Who is using our products? So, I mean, I've got a small subset of some of our clients. So I'm not sure if we can actually relate to some of these names, but these companies have got a very good reputation with helping main contractors. So we're helping subcontractors with takeoff, with measurement, with tender documentation, or say with things like bill of quantities. All of these companies, they're currently using our products to make sure that they're reducing time drastically on their measurement, which then gives them an opportunity to take more projects for themselves or cater to more clients and therefore generate more revenues. So you've got a couple of testimonials. One of them is from Brian Grant, who runs his own company. He's ex-Mace, and he's saying here that he reckons that with Cubicost, productivity has probably increased by approximately 50% for the projects that he works on. Another one from Gavin Powell, who again runs his own company. He's ex-Wilmot Dixon, and essentially he's reflecting the same emotion that if you're using a product, then you'd be in a position to significantly reduce your measurement time. So what do we mean when we say measurement only approach? So I'll just explain that in a second. So the idea is that if you're doing your takeoffs, doing your measurements with the traditional tool, you start with raw measurements. The next step is that you take those raw measurements and you process those measurements to make sure that you align yourself with any rules, measurement rules, you take care of any factor in any deductions, or you build any extra measurements. Now, once you're done with all of that, then there's also the bill of quantities. And the measurements that you've got may not align properly with bill of quantities. So which means that you have to go through another round of processing all your data so that both your quantities and your bill of quantity sheet align properly. And you sort of repeat that process again and again for different parts of your drawing. Now, if there's a change, it means that you end up repeating the whole process again, and that can be quite cumbersome because changes, they happen. Design changes are quite prevalent in the industry. So if you've already done your measurements and if suddenly the architect comes back to saying, hey, we've revised our designs, can you look at those measurements again? That means you have to go through the whole process again, which may be a lot of work given the size and the complexity of the project you're working on. Now, what does our approach offer? So we call it the measurement plus model approach. And what that is rather than start with the measurement, you start with the model. And what do I mean when I say that? Now, some of this will get clear when Ehsan is running the demo, but the idea is that rather than starting with the measurement, you start with the elements of a building. So say if your focus is on measuring columns. So rather than measure one column after another and multiplying that by the number of columns that are similar, you start with adding columns on top of your 2D files. Now, when you do that, what happens as a process is that you're adding elements to your model. At the same time, it's building up measurements. And it's also ensuring that if there are any rules or deductions or extra measurements, that's all taken care of on the go. And if you have a bill of quantities, you can connect your quantities to your bill of quantity sheet, which then means that all of these three things are happening in the background. And what happens if there's a change? It's really simple. All you do is make changes to the model rather than the measurement. Now, because you change the model, that then reflects into your measurements and all your deductions. You also make sure that they're aligned with the rules. You create any extra or you affect any extra measurement if that's the case. And your bill of quantities also change accordingly. So again, just bear with me. As I said, some of this will make sense when Ehsan actually runs the demo, but this is what we call the measurement plus model approach. So because if you're working in this measurement plus model environment, what happens is that you get access to some boosters, which are not typically available to you in a measurement only environment. So what are some of these boosters? So the first booster is that you get a chance to automate measurements. Now, because we work through a model, what we've also done in our software is that we build some automation in, so you can use some of those features to automate a lot of your measurements, if not all. So that helps you save a lot of time. Second, any rules, deduction, extra measurements are factored in on the go. So you're not having to think about them. You're not thinking, oh, I'll create my set of raw measurements, I'll convert them, or I'll process them to produce all these additional details and then get on with my bill of quantities. Because as the model creates the measures, the model creates the extra measures, the model creates the deductions. The third booster is that you also get a chance, once you have all the measurements in place, then it's really, really simple to align your measurements to your bill of quantity sheet. So again, you're not spending half a day just making sure that your quantities, your measurements all align properly to bill of quantities document. It's probably a few minutes rather than a few hours. Once you're done with changing the layout of your quantity summaries, then it's just really simple putting all that information on a bill of quantities document. And the last booster is that if there are any changes in the model, if there are any changes in the design, then you're much better placed to work with those changes or to affect your measurements because you're working through a model. So these are the 4 boosters that you can get access to with our approach. What we'll do as a next step that we'll jump into the demo and Ehsan will actually show you as to some of these boosters that I've talked about. He'll show you the steps and the processes involved in the measurement plus model approach so that you can appreciate it for yourselves. And towards the end, we have an end of year offer that we'll discuss and we'll just end at that. So Ehsan, all over to you now.
So thank you, Animesh. As my colleague mentioned, one of the first things we're able to do is let's talk about Booster 1. Booster 1 is how we automate measures. The automation happens from the moment we import a drawing. In this section over here, and I've imported a DWG and a PDF. From the looks of things, they look exactly the same. The reason for this is because we digitize them, so we don't discriminate between a vector PDF or a DWG file which you may receive. The great thing with our platform is we're able to automate them both and allow you to work with them in a very similar manner. Next, what I'll show you is how we can identify the columns in the drawing. So to do this, we're going to be doing it by layer today. So here I'll select the girth of this column. I'll just zoom in a little bit more so I can focus on it. And once I've done that, we've then effectively isolated all of the columns which exist in the drawing and can now automate them, automatically take. So see, I've identified 45 columns. Not only that, we've automatically categorized them by their shapes and their dimensions. So here you can see the T's, L's, and rectangular shapes. Now, if, for instance, the other method I'll show you today is how we can have more control when you're doing your takeoff process. So if you are after more control where you just want the flexibility, we can cater to that as well. So instead of selecting everything, I could just identify this one. And as you can see, we've got its shape, its dimensions, and its attributes here as well. If there's a group of columns which you wish to identify, like so, we can and if you wish to identify everything in one go, we can do this. So that's booster 1 done. With the second booster, what we do is we incorporate the rules, measures, and extra deductions all in one. For instance, I'll just take you over to this screen here. Whenever we create a new project, we give you the opportunity to say which rule it is you'd like to work with, whether it's NRM2 or SM7. When you select this, NRM2 measurement rules and deductions will be used for anything you take off. So once we do that, we also cater for customization. For instance, if there are any measurement settings or measurement rules which you wish to change or tweak, we can cater for that as well. So now that I've shown you how we can customize measurement rules and have explained that we have got these measurement standards built in, what type of measures do these create is what I'll be focusing on next. So here, for instance, if I just wanted to calculate this entity, this column, and wanted to check what type of measure is it creating, I'll just take you to that. You can see this column is generating volume, area of formwork, as I've only selected one, how many of them there are, and it's weight of rebar as well, based on nominal values. These are attributes which can be tweaked in the girth if you've received this information. So this is some of the information we've received. This is all on the get-go. As soon as we place an item in, if you recall what Animesh said in the beginning, with the measure-only approach, you're having to create your measure and then going through that process. And if you receive any change, then you have to repeat that process again. However, with us, as long as you've identified the column, we've physically placed it in. And the fact that we physically placed it in, they carry these measures. So of course, if the object changes, the measures are automatically calculated as well. Next, I will create a slab. But before I do that, let me just automate some beam takeoff. So as I did for the column section, I will identify where the beams exist in this drawing. Now, I will focus on identifying where the slab is as per this drawing. So it will look for enclosed areas and will populate it. Now that we have this section, I will create a slab opening so I can show you how we take care of deductions. So to do this, I'll just go to the slab opening section. I will create a slab opening. and draw it in. The reason I'm drawing various ones is so I can demonstrate to you how it works. So as you'll see, all the ones which should be ignored will be as per the measurement rules. So let me just run the calculations here. That's done in 2 seconds. Let me just get to the fun part. So here I'll just see what quantities is this slab generating. So you can see this is how the volume is being generated. Any deductions which exist. So for instance, I can see the slab opening is being deducted. I can also get a 3D representation. So here I can see it more visually. So that is my original quantity, so my original slab. And out of all the other openings which are placed in, as they were fairly small, they've been ignored, so concrete's been poured over them, and only the large ones being deducted. Now the same is true for the beam opening as well. So any building element which interacts is deducted accordingly. Now that I've done this, I will move on to show you what our 3D model looks like. So I'll show you the 3D representation. So generally you're used to working via the measurement only approach. However, this is what the measurement plus model approach is, where when you do your takeoff, you're creating physical objects. So you're actually creating a model, and each building element, such as the column, the slab, the beam, any building element we create, it physically carries the measurements with it. Now, to demonstrate that further, I will focus on booster 4. So here, Animesh, I've switched them around just for demonstration purposes. So let's head over to where changes efficiently. We to do this, we're taking advantage of this model plus measurement approach. So I will first of all change this into isometric view so we can see changes more easily. Next, I will make changes to the column section. So here I'll go back to the column. As soon as we go back to the column, you'll notice we hide everything else. Don't worry, they're still there. They all exist. It's just so that we can focus on the building element we're working on. So first of all, let's make a note of the quantities this column is generating. Animesh, if you can make a note of the volume.
Sure, so that's 0.36 meter cube.
Exactly, and also the area of formwork as well. 4.2.
Okay, so that's 4.2 meters square.
Brilliant. Now what I'll do is I'll just go ahead and change the width of this column here. And I will just change the width of just this column. So let me just call this C1 and just make changes to this and changes to 250. If you can see, the changes have only been made to this one here, and all the other columns, they're exactly the same. Now, if I was to rerun the calculation, can you recall what the number was, Animesh?
Yes, I think for volume it was 0.36 meter cube.
So now that's been reduced to 0.3.
Yeah, and for formwork it was 4.2 meters square.
And that's now 3.9.
Okay, cool. Yeah.
So that was for one column. What if you come across a scenario where you need to do it at scale for multiple columns? Here, I'll just show you exactly that. So I've gone ahead and selected all of these the columns with the same name. I'll check what the quantity is for them at the moment. The volume is 7.14. Let's call it 7.1 for now. Now, if I was to make changes to all of them, let's say make it 400 by 400. Visually, you'll see they've changed. Next, if I was to just run the calculations, you can see, let's see what the change is. From 7.140 to 8.16. So irrespective of however many there are, you're able to make changes radically fast. So that was that was it for dealing with changes. We can also work with area of formwork. So for instance, if we were to change the height of a few of these columns, so let's say I was to change just this one to be from 3 meters. So 3 meters is my floor height. But if, for instance, I was to change this to be 7 meters and then rerun the calculation, you'll notice that it gets its own, it gets grouped differently here. So you can see the area of formwork, it gets grouped in 6 to 7.5 meter category. Now the same is true. So for instance, if I was to select multiple columns, you can see now I have 2 different categories, 1.5 to 3 meter and 6 to 7.5 meter. Now, irrespective of your heights, they will all be grouped as per the SMM7 standard or NRM2, whatever you select. Great. So that's it for booster number 4, which I slotted in here. So next, what I'll show you is how we can work with booster number 4. 3, which is now for aligning measures and reporting them to a BQ format. So to do this, I'll show you the report we generate. You'll notice whenever we generate a report, they get categorized in their own tabs. So columns, beams, slab, and so on. Next, you can see we only have ground floor at the moment. So our classifications at the moment is ground floor, a material, concrete, entity type, volume, and so on. And we have the measures. So just to make it more relevant, I'll just copy everything over to a second floor. Before I can copy elements to other floor, I'm just going to correct this one here. So as you can see, I changed this to 3 meters. I'll just bring it back. So it's 3 meters as everything else. And now, as I did before, I'm going to, so now what I'm going to do is copy elements from this floor to the first floor. Right now, I've just copied one column over, but I'll just repeat the process for the rest as well. So that's it. I've just copied the columns over. If I wanted to do anything else, that can be done as well. But in terms of demonstration purposes today, I will just run the calculations for everything. Again, in 2 seconds, that was completed. And now I'll show you the report for both floors, the ground and the first. What you'll now notice is we have a floor breakdown. We've got material, concrete grade, the type of entity. Again, the measures we generate as well. Moving on, we're able to change classification. So consider this to be your report builder. You can set this once, export it as a template. It's not a problem. However, you can also change how you want your report to be displayed completely separately. So for instance, if I just wanted the floor name, not interested in the material or the concrete grade and the entity type, you can see I have my breakdown by floor, name, and the volume. This can then be further changed. So if you just want a total and you just want a total of your volume, here it is. Your total amount of volume for both the floors is here. And then if you just want a total for each floor, again, this can be customized however you like. Moving on, we're able to reverse check exactly where certain quantities are coming from. So here, I've got my ground floor breakdown. I've got the name of each element and the total amount of quantity, so the volume is generating. Whenever I click on one element, it just takes me to it directly. And at any point, I can make changes to the attribute or change its name so it can be classified separately as well. So that was view quantity by category done, or the summary of the quantities we've generated. So now, how do we deal with being able to link your quantities to a bill of quantities document? Well, we can cater for that as well. As you can see, we're working in modeling. We have a BQ section, so you can head over to that directly. When you do this, you can import your Excel document directly in, or link it to our TBQ platform. If you want more information on that, please watch our webinar or get in touch. We'd be happy to show you. Now, if we wanted to link a building element, such as a column, and here you can see my column's been broken down in different grades, C20 to C25, C24 to C30. So let me just add classifications. So again, change my report so that I can get the classifications for them. As you can see, I've only got one concrete grade, so I can just link this here to its relevant section. As soon as I link it, you can see the legend here is being associated. So once you've linked the, once you've associated this column here, what we can then do is we can reverse check from the bill to this quantity summary sheet, and then directly reverse check it to the model. As you can see, we have them highlighted in this section, and I can go to any one to see what type of quantity is generating. Then, if you wish to make any changes to the model, then we can do that here as well. So if I wanted to, I could change all these rectangulars from being 400 by 400 to be 350 by 400. You can see that's been changed. Now, for the changes to be reflected, I would just need to rerun the calculation. If I head back, you'll notice that from 20 it's come down to 19.710. And because I had saved a baseline in the process before as well, that is the change. That is the variation. So it's minus 1.020 meters, cubic meters. That's it from me. Over to you, Animesh.
Yes, and thanks for that. That was a really good demo.